right, is everybody good on this for now? Does anyone need more time on this exercise? What I want you to do going forward is, as you continue to, feel free to use this board as you continue to prepare for your capstone presentations. You can use it as a collective brainstorming space. If you need to make groups, you can use it to do that. By next week, again, we're giving our capstone presentations next week, and so next week I'm going to need to see. I recommend you just paste the links to your slides in here. That way we can just load it up. I'll know who the groups are with this, and we'll be able to just click and start the presentation. So again, I want a link to your presentation in here for next week. That way we can just do it, right? And again, your slides don't need to be super fancy. You can even just use this as your visual reference if you want. Again, as long as we answer those 5 questions, that's all there really is to the presentation. And again, you're welcome to make any sort of groups you like or work on your own. Are there any questions or concerns about that? Does it feel clear? Cool. So I want to turn your attention now back to our friend, the third dimension. And I'm so sorry that we haven't been, the streams have been kind of intermittent. I don't know what's going on. I've set this up good this time, I hope. So I hope that we'll get video as well. If not, I do have a good pre-recorded video of this that we can sort of substitute in. But I'm going to just sort of return to the third dimension. We'll do this for a little bit, and then we'll take a break, and then we'll cover some more advanced stuff in 3D. But a nice sort of reference point for what we are trying to do in 3D is the labs, right? Again, we do also have a lab that is due before the end of the semester. And this one is really straightforward. It's just a 3D project that has a camera, a light source, a simple level made with CSG shapes, and a controllable character body 3D. And I want you to upload it via GitHub. Or if you want full credit for it, you should upload it via GitHub, have a camera and a light source, a simple level, and a controllable character body. Does anybody remember how we start doing that? Like, what's the process in order to complete this?
Wait, complete as in the...
Like, turn this into, like if I were to try and do this lab right now, what would be the first thing that I would need to do?
Make a GitHub.
Right, you need to have some sort of GitHub repository. Does anybody have any questions about how to create a GitHub repository? You should already have some, and you're welcome to just reuse the GitHub repository you've been using for your labs. That's fine too. So I won't go over how to create a GitHub repository, but if you have questions, please ask me. Instead, I'm just going to use the repository we already have for our syllabus. So I can click Show in Finder, right? And this is going to take us to this section. I have this modules folder and this 3D folder, and this is where I'm going to be building this out right now. I'm just going to do this lab assignment in real time for you so you can all see what's required. So right, just here in this, this folder, I'm going to make a new Godot project, right? So I'm going to go ahead and open Godot. And as a matter of fact, as a reminder, right, there's been a sort of major, sort of mid-level upgrade in Godot, right? We've moved from Godot 4.3 to 4.4. Everything we're doing, if you still have 4.3 and want to just use that, that's totally fine. 4.4 just offers some nice new quality of life stuff. And I just recommend before you release, if you're going to make a game in Godot for your final project, I recommend just picking either 4.3 or 4.4 and sticking with it for the duration of the project. It can be a hassle if you try and switch from 4.3 to 4.4 in the middle of a big project, okay? But right now, it really doesn't matter which one you use. But I'm going to be using 4.4 for this demo. I'm going to create a new project. I'm going to create a new project called Lab 4 Review. And I'm going to use the Forward Plus renderer. You know, again, you can do 3D with any of these renderers, and particularly if you want to publish your game as a playable web game, you want to use the compatibility renderer. But if you want to play with the fanciest lighting tricks, you can use Forward Plus. So I'm going to use Forward Plus just so I can show you some more stuff. And I'm going to save it to the syllabus. Again, you would be saving it to your, wherever you save your repositories, right, for your labs. I'm going to select this folder, and then I'm just going to hit create. So that's part one of the lab, right? Just creating a Gato repository. And now we need to go ahead and make a 3D scene, right? How do I make a 3D scene? What do I need to do to make a 3D scene? What's the first step I should take?
Like 3D scene node.
Yeah, right, 3D scene. Yeah, let's just add a 3D scene node. And again, you can use any node as the root node of your scene, right? So if I wanted to have like a camera or, you can have anything be the root node. But it's simplest to just have a node 3D, right? And a node 3D is just like a node 2D, except with an extra dimension, right? So instead of just being two-dimensional, it has a three-dimensional component. It has Z components for all of the position stuff, right? So that's pretty good. We have a scene now, right? I can save this, call it main. Save it, and I can even run this and select the current scene, and bada bing, bada boom, it looks like nothing, right? Why is that? Why does it look like nothing?
Because there's nothing in it.
There's nothing in it, that's true. So we can add something. What did you say, Rachel?
No, I just said you haven't added anything.
That's true. I guess I haven't added anything. So I'll go ahead and add. Right, one of the parts of this lab is to make like a level out of CSG shapes. As a reminder, CSG is a nice like prototyping. They're like primitive shapes which you can easily edit in the editor. So for instance, one of the best ways to just make a floor is to just create a CSG box and then just make the box really big. So I can make the box like 100 by 100. And that's basically like a floor, right? And what's nice about CSG shapes is, when you just use a mesh, again, you have to have a whole collision shape, kind of like our, how in 2D we had our sprites and then we had our separate collision shapes. It's similar in 3D, except when we use CSG shapes, all we have to do is click Use Collision, and then it adds a collision shape for us. So now we have like a nice floor. So this would basically do for a level. So I can save this and run it. Okay, and it still looks like nothing. Why does it look like nothing still?
You need a camera.
We need a camera, right? Because again, when we run things in 2D, it just is sort of automatic. We just have this area that we're working with. But in 3D, it's a three-dimensional space, and we need to pick a place to look at the scene from. So in 3D, we always need to have a camera 3D. Camera 3D. You also notice, right, we have an XR camera 3D. So if you want to make stuff in VR, Gato is really well equipped for it. We can easily do that. We can't do that in this class. Maybe we'll do a little bit by the end of the semester, but we don't really have the time or space for it. But it's not too much of a jump to quickly. Everything you learn in 3D applies pretty easily to VR. So it's actually a really great program for making things in VR. Now you'll see when I move this camera around, you can see over here, this is a nice little 4.4 feature. You'll be able to see the view of the camera. If you're on 4.3 and you can't see it, the easiest way to see the view is to click this preview button up here, and then that'll take you to the view from the camera. And you can even do, I think, you can click this view button and make two viewports, and that'll split the view in half, and then you can have one of them be from the view of the camera. So this is kind of how you can get around this issue of like not knowing what your camera is seeing. And then you can always click view and then go back to one viewport. Or if you're on 4.4, you can just look over here. Yeah.
How to open the preview?
Yeah, so that's because, right, I think you're using 4.3, right?
Okay.
I think, yeah, unless, because again, at the start of the semester, these computers had 4.3 installed on them. In order to upgrade it, you'll need to go to gato.com or .org, right? GatoEngine.org. And then go to download latest, and this will get you. And it's, if you want to do it right now, it takes like a second. It's like actually a very small program, so you can do it in class. But also like that is not like that important. Being like, it just makes your life a little bit easier. So we have this sort of camera, right? We can move this camera around. That's very good. Now when we run the scene, it still looks not correct, right? What are we missing here?
Light.
We're missing light, right? Gato has this nice sort of simulated environment for us, which we can turn off When we turn it off, it looks closer to what we see when we render it, right? And we can see when we turn on this directional light, we kind of get this nice sunlight, right? So if I were to, and we'll talk a little bit about light later, but the easiest way to add a light to the scene is to click this light up here, right? And we click these 3 dots and we have this preview sun, and we can change some of the simple settings right here just to like mess around with things. So you can make like a blue sun, spooky, oh, well, you can make a blue sun. You can make it super bright, right? And then you just click add sun to scene. And what that does is it basically, we use this node called Directional Light 3D, and that just like lets you, these buttons up here let you set some of the kind of most useful settings from that node. But you can always just change them in the node itself as well. So if you want to reset it, you can reset it. Okay, and now when we run the scene, you'll see that it does in fact look like what we see in the editor, right? This other node is a world environment. So a world environment is kind of like all the stuff in the background. You can kind of think of 3D spaces as like, at some point there's like we can render objects at a certain distance, right? And actually at a certain distance, objects disappear. So for instance, if I were to take this object and pull it way back there, well, I'll put it down, I guess, right? If you put it way down there, eventually, whoops, it just disappears. You can see how it clips out. It actually just starts disappearing. This is when we get over like 1,000 or something. So at a certain point, objects just stop getting drawn, and you can change that draw distance. But then what we do is behind all those objects, it's like we have a sphere of either a texture or a color or a shader to kind of make it feel like there's a world around that, right? And so this material, this atmosphere, is just like a circle. It's just like a big circle that is kind of drawing a color around you, but it's drawing it like at the furthest distance possible, okay? And I would really actually like my box back, so I'm gonna click, not the size, but the transform down here. I'm going to restore it and save it. So this is what's called our world environment, and Godot has a nice sort of preview environment which comes with these fun little settings which you can set. So if you want to, again, these are like changing some of the simple settings for the preview environment, and then you can click add environment to scene, and it adds this node to our scene. But there's lots of different types of backgrounds you can have. So for instance, if you just want the background to be a color, you can pick custom color and just set the color of the background, right? And you'll notice too that this also sort of this impacts like the ambient light, the light that is kind of bouncing around, right? Because the sky has a lot of light in it that just sort of gets all over the place and bounces around on things. And so when we just use like a clear purple color, the ambient light from the background actually bounces off of this bottom color and makes it look purple. And you can change the energy, right, to like really be something. You can think of this as like the energy. It's like the whole circle is kind of glowing at you, right? You also have you can do keep, which is kind of wacky. Keep means you don't actually erase anything. So anytime you move, it's just like the drawing gets redrawn over and over again. I don't know what you would use that for, but it's kind of a cool glitchy effect. But the most common thing to do is use a sky, and then inside of sky, you can mess with these different types of sky options. So there's like a procedural sky, a panorama sky, a physical sky. So if you think this looks a little cartoony, you can go and change it to a physical sky material, and that looks like a little bit more photorealistic. And it has these sort of like these are like kind of photography type settings. You can also very easily get what's called a skybox, where you sort of get a special photo and insert it there as a background, but I'll cover that later because we're technically just supposed to be doing a lab review right now, right? So again, here we are, we have a 3D scene, we have a light source. You don't even need the world environment, but I got sidetracked and here it is. And so right now we start the scene, what we see is what we get. It looks pretty good. The final thing that we want is a character body 3D, right? Again, if we go back to the lab assignment, what we want for this assignment is a controllable character body 3D. And that really isn't as hard as it sounds. It's as simple as step 1, add the node. What node do we think we want to add? It's kind of a trick question. If we're trying to make a controllable character body 3D, what node would we use to do that? What? Right, we're trying to make a controllable, a character body 3D, right? What node would that be? We need to add a new node. That's going to be our character. Yeah, right. We just need to add a character body 3D. You just go and say character, right? And again, this is exactly, it works exactly the same as our character body 2D, right? Here's our character body 2D. Here's our character body 3D. We just add it to the scene. It's going to complain just in the same way that character body 2D complains, right? It says we don't have a collision shape. We need some sort of collision shape. So we add a new node called a collision shape 3D. This is the same problem as in 2D, right? We need to give a shape for this collision shape. So I'm going to go and click shape. And a good shape to use for 3D characters is a capsule, because it's kind of person-shaped, right? And now if I zoom in here, you'll see here it is. It's just kind of small and in the ground. So what I'm going to do is I'm going to take my character body and drag it up. Okay. And then this is all you technically need to have a controllable character body. We just can't see anything, right? But if you wanted like a first-person game, for instance, you could just take the camera and make it a child of this node. I need to find the camera, though, and probably bring it back to, closer to this person, right? So I'm going to go back to the camera and transform it and just reset the transformation property. That's going to snap it to the position of the character body. Also, I've been doing this a little bit, but if you're ever like lost in 3D and you want to find your node, you can click on the node you want, hover over the main viewport and press F, and that'll snap the viewport camera back to center your thing, right? So you can kind of see here I have this collision shape, I have the camera, and I have the character body. The final thing I need to do is just right-click on the character body and attach a script. And you'll see, just like character body 2D, character body 3D has a really great basic template. So you just click create, and this is good. You're done. You can just hit play now, and now I can just use the arrow keys to move around. You can't really tell because the floor is so big, but once I get going, you can kind of see. You can move left, right, up and down, and you can even jump, and that works really well. And if you jump off the edge of the world, you will fall forever. That's on you. And that's all you need to do for lab 1, right? So, or for lab 4, is to just have a scene with a camera and a CSG shape that you can like use as a level, and a character body with the built-in template. So you just need to save that and then submit the GitHub repository. Are there any questions about how to do that? What I'll say is, right, sometimes you don't want to have a fully first-person game, or even you just want to be able to see a little bit more clearly, like what your character is doing. So what you can do is you can click on your character body node, and then we can add another node called a mesh instance. You can kind of think of a mesh instance almost like a sprite, right? Like this is just going to be a shape without any collision shapes to it. It's going to be like a drawing of a shape, but it doesn't actually have the collision data attached to it. So I'm going to click Mesh Instance 3D and hit Create and pick a mesh, and then we have a little bean, right? And now we can kind of easily go from a first-person game to a third-person controller, where we just move the camera out and then maybe make it look down a little bit. Make it look up a little bit. And then now I have this sort of like third-person game, right? Now this isn't a very good third-person game, because typically in third-person games and in first-person games, you want to have some sort of control over the camera, right? You want to be able to use the mouse or something, or a joystick to look left and right, right? That's more complicated, right? That requires coding. You have to kind of build that yourself. I have 2 templates which I'll show you I'll show you those after the break. But it really is a matter of just kind of using code and a couple of other nodes to build this out to be an actual like camera controller. Okay. Before we take a break, are there any questions about some of this basic 3D stuff? Yeah. Great. Let's hear it.
So I set the light in this color.
Uh-huh.
And it shows like yellow.
Yeah, that's a good question, right? We have a sun light. Let's see if we can recreate it up here. We have a world environment which just has like looks like it's a procedural sky, and the sky is kind of like you know what? I'm actually just going to delete it and then use this one. But this one is, you got kind of like an orange going on, and then sort of a dark blue. And then you set so we'll add this environment to the scene, and then we have this directional light, but this directional light has like a, what color would you say that is? That's like a teal color. Right, so you'd think it would look kind of like that. However, yours is kind of looking maybe, let's see. I suspect that, what I suspect is, I'll delete this one more time. Click up here. Did you change the sky energy a little bit? Maybe, which you can see the sky energy by going to the environment, and then you can always search for properties. So I'm just going to search sky. Looks like this sky contribution thing is turned way up, maybe? Basically, like the way that ambient light sort of works is, let's see, sky. If you click, if you open the sky, and then go to, if you open up this, and then open up the sky. Let's see the directional light. Try resetting its energy just to 1. Try turning the energy way up. Very weird. I don't know why. I suspect that it has something to. I suspect that there is some setting inside the sky somewhere that is creating like an ambient light like that.
So it's still 4.3, right? These computers.
Yeah.
So whatever default might have changed.
It might have changed. I don't think they've changed. I don't remember them changing these defaults. But that's also possible. There might be a slight difference. It is just a matter, if you want to fiddle with it, what you could try going to the world environment, and then try just like hitting reset over here. Yeah, so see now, so that is, you can always get that back by undoing, but there's some setting, I think it's probably the energy from the sky that's kind of washing out and overpowering the sun. There's another question, yeah?
Okay, so I forgot how to make the creation shift 3D. I think I created, but it's like keep
Yeah.
going across to platform.
Oh yeah, so if you're just falling through the ground, one thing that you might not have done is if you have your level, is your level a CSG shape? Does it say CSG box?
Yeah, right here.
Yeah, and then on the level, did you turn on use collisions?
Okay. Okay, I clicked it.
You clicked it now?
Yeah, I turned it off.
Okay, try it again. Oh. Yeah. So what's happening here, is we have a character that is kind of falling sort of through the ground, right? So like, if your game is going like this, what? Come on. Why is it? Oh my God.
I feel a little bit.
Yeah, if your character's falling a little bit, what's probably happening is, sorry, Sorry, let me just get some light back. That's good. Okay. I suspect what is happening, or no, actually, oh, it would be the other way around. That's what it would be. This collision shape would be probably up here. Right, if you fall down a little bit through the ground, that's because your collision shape and your mesh are not aligned, right? So here in this case, I have the mesh is here, but the collision shape is here, right? Can you guys see it? It's sort of hard when it's all blue. It's really tough to see. Basically, the best way to fix that is to go to your, I'll change the debug color of this maybe to like a yellow or a red. Nice and red. Yeah, there we go. That's visible. Yeah, so right, so we can currently see that the shape is off, right? The shape is above the mesh. So what you want to do for that, I think the easiest thing to do is to take the collision shape and the mesh instance. You can highlight both of them, and then you can go to transform and just reset their transform to 0, 0, and that'll make them both match up to the position of the character body. So yeah, in 3D in particular, if your meshes aren't aligned with your collision shapes, you'll get weird things where you're like going through the surfaces, right? Because again, it's just the collision shapes themselves which actually calculate what hits what. Does that make sense? Still having a problem? Let's see. So click the collision shape. Can you press F? Here, click the collision shape, and then press F for me. And zoom in a little bit. So also, this one looks like your capsule is not the same size, right? Here, let's try dragging it up. Maybe. Drag it higher. Oh yeah, see how your capsule is really small and your mesh is really big. So maybe also try resetting. Let's click on the mesh instance. In the scale, you have like or try just resetting. Here, hit reset and reset. Yeah, and then now go ahead and go to the collision shape and reset its position. Yeah, and that should make it all line up nicely.
Yeah.
Cool.
Thank you.
Yeah, and so like that's a thing, right? Like sometimes you have meshes that you set in a certain way, right? Like let's say you want to make a mesh and you want your mesh to be taller, right? Maybe I want this guy to be like nice and big. And I don't want to just make I don't want to have to do the collision shape by hand. I think I showed this briefly last week, but what you can always do is if you have a mesh that you want to give a collision shape to, you can just click on the mesh node, then go up to this mesh menu up here and click create collision shape. And then you can say create sibling tri-mesh. And that's just going to create a regular old collision shape. And I'm going to delete the other one. And this is now a collision shape that nicely matches the mesh that you just had. And oh, I guess I'm using the wrong type of mesh. That's rude. Or collision shape. Create collision shape. Let's say try single convex. See if that works. Yeah, that seems fine. So if you're going to use a character body, you should just use a single convex mesh. Anyway, why don't we go ahead and take a break now? Let's take a 10-minute break and come back at 4:50, at which point we will go back and talk about materials, materials, models, lighting, sound, monsters, and the future.
The future?
Maybe. It'll be in the future, so.
我前面没听到，要靠它本来好好的，突然卡住了。
This is a really big character.
没有啊，那我还能跳舞。
Very broken.
我不知道，我只会跳，我只会蹦跶。不是，他是能跳，但是他没这个手。加一个 script 的点，添加脚本就好。
不用写的。
直接存就是它的自动带。
Looks, let's start learning again. In Gato, guys, can we continue this after class? Thank you.
Sorry.
That's okay. Looks great. Looks really good. So we've started kind of messing around with some very simple 3D environments, but there's a lot that we can do to enhance our environments, right? So, and one of the best places to start looking is inside this world environment node. This world environment node has a lot of different things that you can mess around with to really change the way your space looks and feels, right? So for starters, a very classic effect is to add some fog. So you can just click fog and hit enable. And that will immediately give you a color fog, which you can mess around with to change. And it really starts to show itself once you have a few more objects. So I'm going to go ahead and make a couple more nodes. I'll use like a cylinder. I'll make it nice and big. Right. Tall. Maybe I'll duplicate it. Drag that one over there. Right, and kind of see, like, you know, when you have fog, you have a bunch of parameters. You can mess with the density, right? So here's a nice dense fog where, like, things really sort of fade away. And the higher you turn up the density, right, the deeper the fog is, right? The closer your field of view ultimately is. This is a really nice effect if you're trying to make something spooky, right? This is like a very classic. If anybody's ever played like some of those classic horror games, like Resident Evil and all that, like the original titles, they would just sort of add a really thick fog around things, and then you can sort of have things appear far away, and that's a pretty effective effect. You can change the color of the fog, right? You can also change the energy of the fog. And this is a pretty good basic fog. This will work on compatibility mode, which is great. But if you want an even fancier fog, you can use what's called volumetric fog. This only works on Forward Plus, but if you turn on volumetric fog just really looks, well, kind of a lot more like fog, right? You can, and it really, what it does is it also picks up light from your light sources, right? So if we have like a directional light, you can see that it kind of like picks up the actual light from that, and if we sort of change the shadow, the angle, we can kind of see it sort of like passing through the atmosphere, which is really cool. If we use volumetric fog too, we can also increase the density. And you can also even make it emit its own light in and of itself. So if we go to emission, the emission property of materials is what constitutes the light that is emitted from them. So we can even make this fog kind of like glow and do all sorts of wacky stuff. Fog is a great way to just sort of add some quick vibes to your scene, right? And again, with all of these sorts of nodes and techniques, it's really about just sort of playing around with all of these settings and seeing what you like best, right? We also have, you have a glow, which you can add. So if you enable glow, then you can sort of change its intensity and strength. Strength. And that's when it sort of starts to create this sort of like glowing thing. You also have the bloom property, which allows you to sort of create almost like a bloom. Well, it's called a bloom effect, and you can change the different levels of the bloom effect to really just blow everything out, right? Maybe you're like dying and going to heaven. I don't know. There's all sorts of stuff, right? You can get really, really weird when you just start playing around with this stuff. And you can get very abstract too, right? You know, your games do not have to be photorealistic by any sense. You can also temporal reproject. I don't even know what that means. Anyway, sorry. You can also add to your scene you can add camera attributes, and you can either add physical or practical. Some of the easiest ones to use are the physical. You click on that and you open up, practical. If we open up the practical, then we can do things like change the exposure. So if you're familiar with photography, you can sort of change the exposure level of the scene. So you can make it overexposed or underexposed. You can you can make it automatic exposure, which you can then sort of mess around with. You can add a DOF blur, which is that stands for, what does it stand for? Depth of field. I was like, degrees of freedom? That's a different DOF. Depth of field. Right, so you can add a depth of field blur to make things after a certain distance be blurry, right? So we can see this is things far away are blurry. You can also add a DOF near enable, so that way things close to you are blurry. And if you shrink that down, no, come on. Maybe this to be really small, or maybe this needs to be bigger. Anyway, let's see. This is like a nice way to sort of create like a spooky little out of focus effect, right? And this is all stuff that you get pretty much for free. It's not too, this works is very performant, and I think these, I'm pretty sure that these camera attributes are also even still on the compatibility renderer. You can also add a compositor, which is probably too complicated. Yeah, we're not going to talk about the compositor, but you can do a lot of crazy tricks with the compositor. There is a fairly simple, it's in the, where did it go? Everything gets moved around. You can turn on adjustments. There they are. Adjustments allow you to then actually do things like change the brightness, the contrast, the saturation. So if you want to make like a noir game, you can do that. And you can even add a color correction. And if you do a color correction as a gradient, and you can really go nuts, where you can sort of make everything that's black. Maybe you want your black colors to be like red, and you want your white colors to be pink or something, right? So you can really kind of go nuts with all of these sort of different types of effects. So a great way to build out your environment is by literally messing around with the world environment, right? But that only goes so far as having good stuff to look at, right? This is all still pretty basic, kind of boring shapes, right? I'm just gonna turn this off, and yeah, we'll stick with the spooky vibe. So some of the easiest things you can do to enhance your environments are by using textures and by using models, okay? We did models briefly last week, but I'll show you again. One great place to get models from is the asset library. So you can go to the asset library, and unfortunately it doesn't have a great searching. I'm gonna try searching model. And that'll pull up these fantasy models. I know that there's this artist called Kay who puts his kits up here, so I'm going to search for Kay. He has a bunch of 3D models here. So you can go ahead and grab some of these models if you like. For instance, if you want to make like we'll go with the spooky Halloween business, right? I'll just go to Kay Kits Halloween. I'll click download. And what's nice about getting them from the asset library is that it pretty much just drags them into Godot for you. So you just click install. And it'll just download these files. But as you'll notice, right, these are both OBJ files and GLTF files. So there's OBJ, GLTF, FBX are three very common file formats. And Godot very handily supports all of them. So I'm going to show you how to import these assets, which it's taking a while because there's like a bunch of 3D models. 3D models are kind of some of the larger files that you can work with. Along with high resolution textures. But once you do it, once you add it on, this particular add-on, it's just sort of here in the add-ons folder. You can open up assets. And then it really is as straightforward as just taking the file that you want and dragging it into your scene, right? Here's a coffin in our scene. Boop, boop, it's right there, right? And again, if you want to be able to hit the coffin, right? Because right now, if we were to just run this spooky scene, let's see. Oh, it's already running in the background. Oops. Oh, right. And I was going to show you how to make camera controllers, right? I'm currently just walking through this, which is not very helpful. So in order to make this something that you can actually collide with, you need to create a collision shape. So you could very simply just, you could also just like add a collision shape, 3D, make a shape that's like a rectangle, and then kind of like whoop, whoop, whoop. And that's gonna be, whoops, that's kind of gonna be good enough, right? Maybe I'll make it a little bit wider so we can't clip through the edges. And this is really what I mean is that collision shapes do not need to be perfect. They just need to be good enough that it convinces the player of the illusion, right? So like now, oh, sorry, no, that's not gonna work, sorry. You can't just have a collision shape, you also need a static body. So I'm gonna add a static body, and I'll make this collision shape a child of that static body, and that's gonna work. So now I hit the coffin, right? There we go. I'm just like running into it. But it's not perfect, right? You see that it's like, you can tell that it's kind of square shaped. I don't care, but if you care, if you want to get more precise about this, you're going to need to take the mesh of this and create a collision shape from the mesh. And all 3D scenes, they get imported as their own scenes, and then when you go inside them, Gato starts to be like, hey, are you sure you want to mess up with this scene? This is like a special file. And this is kind of a confusing point for people. I typically like to just open the scene anyway, and then here's the actual mesh itself. And you can just copy this mesh and bring it back to your scene and paste it. And then we can actually just delete this. And then, well, maybe not all of that. I'll take these guys and drag them here. I'll just delete both of these. Boop, boop. I'll drag this out. I'll delete this one. Here's the mesh itself. I can click on this mesh menu and I can click create collision shape. And then I'll just create a static body child, which is just gonna make a child node called static body with a collision shape based off of this mesh. And there it is, right? It's made a special mesh now that is kind of a special collision shape that's kind of exactly the shape of the coffin. And so now when we run into it, it's like nice and kind of fancy, right? I can walk right up against the edge of it and then walk against the other edge. So that's a really straightforward way to add models to your scenes. But again, right, there are so many other places to get models, right? If you make your own models in Cinema 4D or Blender, you can easily import them in exactly the same way. I'll check out Itch for some 3D models. Itch isn't the best. Itch is kind of more, skews a little bit more towards 2D assets and stuff, but they have, this whole sort of like retro horror, old PlayStation style is really popular right now. And so you can find a lot of assets like that. So if I go to assets, and then I'll do a tag for 3D. So there's all these assets. There's this, let's get like something kind of fun. Yeah, let's get these retro trees. Why not? Right? Because again, right, your games don't need to look realistic. They just need to have a style and a vibe, and this is a pretty clear style and vibe. I'm gonna download them, right? Unzip them. We have the models, which are FBXs, and we also have the textures, which are just PNGs. Let's bring this folder into Gato. Not inside of this thing, probably just here in the root folder. Here's our trees, here's our models, and I hope that it's just gonna work. No, it's not. Wow, this is a big, what is happening? It's a big bush. So the tricky thing about models sometimes, right, different model file formats come with the textures attached or not attached. And FBX is kind of somewhere in the middle. So frankly, what you can do is we can create materials with the textures on them. That's a little bit of a hassle. Right now I'm just trying to show you imports. So what I would be doing in this situation is, frankly, I would be finding a different model. So I'm going to go back to Edge, and I'm going to look for some different things. I particularly like using GLTF because it always has the textures and the materials attached nicely. It's also an open source file format, so I appreciate that too. But let's try these cars, these old-timey cars. So we have the cars as a Blender, OBJ, OBGG. Okay, we're not gonna get the cars. Let's get this thing. What's this? Classic 64. Sure, we'll see what happens. Download. Oh my gosh. Oh boy. These are all Blender files. Blender is also actually very good with Gato, but it's a little out of scope for this class, so I'm not going to show you Blender either. We'll try one more, and then I'll show you a different website. I will try this school classroom. What could be more fun than modeling a school classroom inside a school classroom? Our imagination is unparalleled. Great. GLTF and FBX, no walls. GLTF and FBX. Great. We love that. I'm going to open this up, unzip it. GLTF. I'm going to take the GLTF and GLB files. I'm going to ignore FBX, and I'm going to bring these into Gato. So there's a little bit of work to do to find the right things, right? And again, it's very possible to make this thing look like a retro tree. It's just not exactly what I want to be showing off right now. But I will just close all of this, close the trees. We have the GLTF folder, and we have a door. That's a door. Hooray! Look at that. That's a door. We just brought a door into our game. We have a wall window. Wow. And a lot of assets are kind of modular like this. You can kind of like really sort of just create whole rooms by sort of dragging them out. And then if you hold Control, it'll sort of snap things to good points while you're dragging. Sometimes not. You can really sort of just like make whole little environments this way. Right? It's a bit of work to do this, but it is very possible. Right? Here's a room with a door. So straightforward. Any questions on importing models, on how to use models effectively in Gato 4?
We can also import the material like from our website.
Yes, yeah. So for instance, there are plenty of model websites. There's so many model websites. There's like TurboSquid. TurboSquid is a good one. You can search for like anything here, right? And you can import any of these models. There's so many of them, and they often are like, make an account, blah, 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 blah. But anything that you get will work, right? There's CG Trader. There is a pretty good one from Unreal. There's the Fab Asset Store. That's a new one. Store. If you go to Fab, and then we look for, they have all of the very fancy looking assets and such. And even though they say it's just compatible for Unity and Unreal, they're also, like, the 3D models are just 3D models. And you can pay for models. You can also use features, right, for free. Price free. Plants. Here's some nice plants. Yeah, you can basically just download these and install them just essentially by dragging and dropping. What you can also do is there's a whole other type of thing called materials and textures, right? And there are lots of great places to find materials. I'll say like 3D materials. I think it's Polyhaven is a good one. Textures.com is really good. And what these are specifically for getting like actual. No, this is not the website. This is 3D printing. Polyhaven, come on, Polyhaven. And I'm streaming all of this, so this is on the stream. Polyhaven has models, but Polyhaven I think of more as having textures and materials. This is really good for like surfaces of stuff, right? If you want like a granite wall or rusty metal, right? You can take any of these and let's see. Let's try and take this one. That's kind of fun. And when you work with materials, what you need to do is you need to download. They basically come packaged as a bunch of static files, right? They actually look kind of like this. So you have a one picture that looks like this, another picture that looks like this, another picture that looks like this, another picture that looks like this, a picture that looks like this, and a picture that looks like this. And these are all like information channels. This is all data. So this is the normal map of the material. This specifically tells the game engine how to render the shadows, right? When a light ray bounces off of it, what direction should it go when it hits this point in space, right? This is actually like a direction that it's telling the light to go. So this particular image is used to like tell the computer how to make it look shadowed, basically, right? This particular texture is the actual color. This particular texture is ambient occlusion, which is about like where it should be. You know, sometimes light gets sort of stuck in little corners, and so things get slightly darker the deeper they are. So this is kind of like a little extra shadow layer, basically. This one is probably the height map. So this is like how high up it should go. They all, you know, everybody does them kind of differently. But essentially, right, what you do is you download these files. I don't have Blender files. I don't have Blender on this computer. So you can download them in a bunch of different file types, but even just regular old PNGs will do. And you don't need all of them, okay? I'm just gonna take the ambient occlusion. Okay, I'm gonna go and click ambient occlusion. How do I click the download? Okay, I'll do this. I will do, that's fine. Close this, close this. All right, we're gonna speed run this. I'm gonna download the ambient occlusion, the roughness and metal. I'll do displacement, diffuse, normal, rough. I probably should have just done them all. Where's the actual texture? We'll find out. Now we have these files, right? And these are just pictures. So I'm just gonna save this into our repository. I'm gonna make a new folder called new folder called material, and I'm gonna, well, okay, it's just gonna be there. That's fine. And I'm just gonna save each one of these there. Right, so I'm literally just downloading pictures from the internet. And you can use any picture. You don't need to use these specific coded pictures. If you do different pictures, you'll probably get a weird glitchy effect, but that's absolutely also an art style. But once I get enough of these, what I can do now is I can go back to Godot, and we're importing all those assets. And I'm just gonna make a new scene because we already have this like lighting and stuff. It's probably hard to tell. So I'm gonna do a new scene, new 3D scene. I'm just gonna reset the sun to something kind of normal. Reset the energy. Reset the sky. Turn off glow, tone map. All right, that's good. Sure, that's not too insane. So I'm just going to use the preview environment. I'm going to add a mesh instance, right? I'm going to go and have a mesh. So this works for any sort of mesh. So a model mesh, a CSG mesh, any shape, right? Because again, when we make objects in 3D, we have our meshes, which are kind of like our bones. Then we have materials, which are kind of like the skin that is on top of those bones, right? So I'm going to go ahead, I'm going to add a material. So I can click, there's a couple different ways to add materials. You can either add the material inside the mesh itself, or you can do a surface material override. It's basically the same. I wouldn't really worry about which one you're doing, but I'm going to add a material. And then here, inside the material, this is where I get to add all of this stuff. So I can go to the albedo section. And again, albedo is just kind of like the color, the base color, but it's also like the base texture, right? So in here, in this folder that we just made, I have this, this kind of color texture. I'm going to bring this over here just by dragging and dropping that. And it got scaled up in a crazy way. So what you can do there is if you don't like the size of it, you can go down to the UV mapping and turn on triplanar. And turn on triplanar. This is going to shrink it down better. No. Maybe it's world triplanar, I think. Again, it's all just sort of pressing buttons until it works. Scale. Change the scale to 0 to 2. No, to 2. Okay, that seems to do it. 10, too big. 5, not big enough. Yeah, it's a pretty big mesh. Okay, I'm going to show you the rest of this, and I'll come back to making it fit nicer. It's hard to just take a material and arbitrarily apply it onto a random shape. You sort of have to do work in order to get it to fit nicely. But you definitely can. It's a matter of like sifting through these and kind of doing a lot of clicking and dragging. But the next step is to go to the normal map. I'll go to the normal map and enable that. And I'll drag the normal map over here. All right, this is the normal map. Where did it go? It just disappeared. Oh, weird. But you can see as soon as we add it, right, even though it's pixelated, it's kind of reflecting light a little bit better, right? If I were to get rid of it, right, it looks very flat, but if I bring it back, it suddenly looks like it has depth. And that's because the light is bouncing off of this in a pretty decent way, right? You can go to height and turn on the height map. And once we turn on the height map, we're going to apply the height map texture, which I think they all use sort of different names. Typically, you know, displacement is also another name for height map. So you can use this displacement texture. And this in particular also needs a little bit of massaging. So you can change the scale of the displacement. It looks weird, right? It's sort of like pushing it out in this weird way, right? This is a pretty often, you kind of want a small number for this to look good. And roughness. Yeah, roughness is another good one. We can go to roughness and add a roughness texture, right? Roughness. Another thing you can do that is actually probably even better to do is to get a more high resolution texture, right? This is actually only, it sounds crazy, but this is only a 2K image, and textures actually, you know, the higher resolution you get, the easier they are to just slap onto things because they're bigger pictures, right? So textures are something where you, if you get a much bigger image, right? If we switch to like 4K or 8K, that would actually look a lot better. I'm getting way in the weeds here on textures and materials, but is this, does anybody have any questions about textures or materials? Or you want me to move on? Sense and a drag. Right, textures and materials, you could spend your life, and it would be a very satisfying life messing around with them. I will move on though. So we'll save that as pillar. And we'll bring it back to our main scene. Oh, whoops, no, canceled. Pillar. Save. Right, and then back here in this spooky main scene, you can just bring it in. Right. Now, let's say that we don't want to have, and you can kind of see, right, when we have a nice light source, it actually does pick up light decently, right? It kind of is scattered pretty well. So it's not actually that big a deal. If you want a environment that is not necessarily the sun all the time, right? That's a good instance to start using other types of light, right? If we turn off the light node, the directional light, and we go back to the world environment and change this fog, right? This fog is really doing a lot of this lifting here. I'm gonna turn off the emission. Yeah, goodbye. And if we turn off the sky energy, right? Let's say we want to make a scene that's like less bright. That is something you can turn down. You can turn down the sky energy, right? Turn that down a little bit. And it's kind of wild that it's glowing like this. I don't really know why. Oh, that's because we have a glow turned on. I'll turn that off. And I'm also just going to turn off these this blur so that we can just see things a little bit better. Okay, so this is like a nice dark scene. There are several different types of light nodes. One of the easiest to work with, I'll only show you two. We have the OmniLight 3D. An OmniLight, right? If a directional light is used to model the sun, you can think of an OmniLight as a light bulb, right? And it's kind of in the icon, right? It's just a point light that emits light in a circle. And you can change the volume of the circle, right? And you can change the properties of the light. So you can change the volume, the range. You can change the attenuation, which is like how sharp it is. Well, attenuation is kind of more like the, just read it, right? It's the, well, it just says the attenuation. Sort of like I think of it as like how far it travels within the range, right? What's the rate at which it falls off? I'll just do 0.1. You can change the shadow mode. You can really mess around with these OmniLights. So these are really great for any sort of object that you want to have be like a light source, like a light bulb. The other type of light that you can use that's pretty easy is a point light. So we can do point light. Nope, spotlight, sorry. Spotlight 3D. Spotlight is a lot like the OmniLight, except it has a direction, right? So instead of just being a circle, it is literally like a light source. So this is great for like an overhead light or a flashlight. So if you're doing anything spooky, spotlights are great. And with those, you can change kind of these two properties of this cone, right? You can change like how tall the cone is and what the shape of the bottom of the cone is, if that is making any sense, right? Like this one allows me to make the cone longer or shorter, and this one makes it kind of like more or less, the circumference of the circle bigger. Does that make sense? Right, and then the spot also has a bunch of other properties too, which you can fiddle with as well. It's all about fiddling. And really, like with these pretty simple tools. You can kind of get most of the way there in terms of like crafting an immersive, interesting 3D environment, right? And if you want to create interactions in 3D, that's like actually the same type of work that you do in 2D, right? That's just a matter of having like area 3Ds, right? Okay, that's a thing worth mentioning. Instead of an area 2D, you just use an area 3D. We have all of the same nodes that we use in 2D, we can use in 3D, and the logic of creating things that are interactive is essentially exactly the same as you do in 2D. There's just kind of a little bit of extra stuff that you have to wrap your head around in order to create like 3D environments. Does that make sense? Are there questions or curiosities you have about the third dimension? Yeah.
I guess the mouse camera full thing.
Yeah. So that is, right, that's a sort of slightly more involved thing, right? So in order to make cameras that follow the mice, or that follow a character, right, we typically have two kind of models for characters in the third dimension, right? We either have like a first-person view or a third-person view. So I'll show you both real quick. A first-person view is easier to do than a third-person view. It's less complicated. That's partly because you don't need to have a character that have animated, right? You can literally get away with not having any character body, and you can still have a pretty good first-person game in 3D. So I'm going to go to this modules folder, and then we have this first-person controller demo. And the way that this works is pretty straightforward. Wait a moment. Bloop, blop, bloop, blop, bloop. Okay. So I just have a simple scene here, right? We have a level. This is basically exactly what we just had a minute ago. You can tell that I like purple. We have a character body. The character body has a collision shape and a mesh. The only difference is we have a node called neck, which is just a node 3D that I've called neck. You can call it whatever you want, but it is basically kind of like your neck. And then as a child of that node, you want to have your camera, okay? That's important. That'll be important in a minute. Then inside the code, right, this code here, all of this is just exactly what's in the starter template for the character body. I think I changed this to left, right, up, down instead of UI left, right. So I believe in this project I just did WAS and D for the input. So that's the only difference there, is I just made these actions. But what this is doing is this is creating a vector. And then what we need to do is, we need to do this. And this is a slightly complicated procedure. Basically what we're doing here is we're figuring out what direction our neck is facing, and then we're using that to multiply our input vector, and then we are normalizing it. Okay, that sounds gross, right? But I think it'll be clearer. I'll sort of I'll do it step by step. I'll print out the direction here, so we can see the direction at least, right? Wait, no, hold on, sorry, this is wrong. How did that, why did I save it? That was the whole point. Okay, save, right? Good. Okay, so you'll see that, right, what's happening is when I move in this direction, okay. Essentially, the input direction is just button presses, right? If we printed out the input direction, you can see that we're using this function called input.getVector to create this vector. And all input.getVector does is you give it literally 4 directions, 4 button presses, and it creates this sort of 3-digit number, right? And this is helpful for figuring out a direction that you want to move in. But the problem is when you, if I were to turn, and sorry, this is getting really confusing because we're printing out both. So when we have input.getVector, right, we see that it's just this number here, right? It's we either we're moving -1 or +1, -1 or +1, where I'm removing -1 or +1. Does that make sense? A little bit? Yeah. So that's what input.getVector does, is it turns these button presses into these numbers. The problem is, right, when we rotate our camera, that doesn't change anything, right? Like that's still, the button presses are still exactly the same. So what we need to do is we need to figure out what direction our camera is facing and then turn that that 2-digit number into a 3-digit number. So that's what we're doing here, is we're saying we're making the X component of the input the first digit. We're just skipping the second digit and we're doing the Y component as the last digit. And then when we normalize it, we just make it so that it is within a nice range. And so then from there, we just move in that direction, and we call move and slide. And then the final part, that only works if we're also figuring out, if we're like rotating our neck, right? So this works for like moving the body relative to where we're looking. But to actually move our neck around, what we need to do is, first what we do here is we want to like make the mouse disappear, actually, right? Because if we don't have this code, if we just don't have anything to deal with the mouse, and we're trying to make a first-person game, when we start moving our mouse around, when we go off the screen, then it gets weird, right? And typically when we have a first-person game, we don't want to see our mouse. So what we do is first we say, we can use this if input event is mouse button, right? This is in the input function, so we have this event, and so this is saying if we click the mouse, then we can say make the mouse disappear. Input.mousemode equals input.mousemode captured means we capture the mouse. So what happens now is when we run the game and we click, the mouse disappears, which is very helpful, right? But it's also helpful to be able to get the mouse back so that I can quit the game. So this second line here says, or if you press escape, we set the mouse mode back to normal. So that's all that these lines do. And then what we're doing here is we're saying if we move the mouse, right, if our input event is us moving the mouse, then we just say we rotate our camera, that we rotate the X component of our camera by the amount that we're moving, right? So this event.relative is, I'll just print that out, print event.relative. I'll comment this all out. When we move the mouse, this is the relative motion of the mouse, right? So if I move it to the right, we can see that the number increases to the right, and move it to the left, the number decreases to the left, and the same by going up and down, right? Just moving the mouse around, when we have this event, when we print out the event.relative property, that gives you this like nice little 2-digit number. And then what you can do with that is you can rotate the camera, right? We can rotate the X part of the camera by our Y digit, because we need to be moving. I'm sorry, I thought this was going to be more straightforward than it is. What I want you to really take away from this is if you want to make a first-person game, you can take this template that I have for you and just use it. And that's the big takeaway, but I do think it's worth it to try and explain what's going on. Essentially, when we have a camera, right, and we're rotating it along the x-axis, you can kind of see, here's the camera, right? When we rotate it along the x-axis, that's sort of like looking up and down. You guys see that really faint purple line that's moving up and down, right? So if we rotate this camera on the x-axis, that's sort of like looking up and down. And so if we do camera 3D.rotate X by the amount that our mouse is moving up, then we just make that really small. Then that basically helps us move the camera up and down. So when we move the mouse up, the camera goes up. And when we move the mouse down, the camera goes down. The tricky part is if you tried to do that with the camera on the x-axis, things get really broken really quickly. Because if we rotate on the y-axis for the camera, everything just gets all weird because we're sort of like rotating and then we're looking up and then we're rotating and we're looking up. So like because it's because we're like talking about our global positions or our local positions, like we have this sort of really weird motion behavior. So what you do instead is that's why we have the neck. So we have instead of rotating the camera, we're just going to rotate the neck. And we're basically doing the same thing, but with the Y position of the Y component of the neck, because the neck is this point here. This is the Y component. So when we rotate the Y component, it's kind of like the camera is looking left and right. Does that make sense? A little bit? Again, you don't need to understand this. You just need to know that if you want to do this, all you got to do is copy these files. Okay? It is my hope that you understand it, but I also understand that this is a lot all at once, right? The final part of this is, right, if you don't do anything from here, you get this weird problem where you can move up and you can keep looking up all the way till you're upside down, and you can just do that forever, and maybe you don't want that in your game. So you kind of need to pick a point where you say stop. You can't look any higher than this high. So what we do, or you can't look any lower than this high. So what we do is we say, okay, after we've done all that, the rotation of our camera, right, our x-axis should be clamped. It should go no lower than negative 30 degrees, which is like down here, and no higher than 60 degrees, which is up here. And this just allows us to say, okay, now I can look up to the sky and I can look down to the ground, and that's all I need, right? So is anybody still alive? That's a lot. So now let's do third-person cameras, huh? It's harder than that. No, what I'll say again, right? This is all theoretically being recorded. I'll also say, if you want, there's plenty of people who can explain this a lot better than I can. So, right, if you're trying to figure this out, you can also just do Godot for first-person camera tutorial, and just take a peek yourself, right? There's nothing wrong with teaching yourselves things. This guy's pretty good. This, and you can also use the length of the video as a nice metric for like how complicated it is, right? There is if you want really short and sweet tutorials, camera tutorial. If you want really short and sweet, there is a pretty decent guy called GWiz. I think he's a little much, but his tutorials are good, right? This is like a 5-minute video which you can watch, where he doesn't really explain how it works, but he does show you all the basic steps you need to do to make a third-person or a first-person camera, right? So, as a matter of fact, I'm pretty sure I got this from him, right? So, if you want an even conciser version of this tutorial, you can check out this GWiz guy. Same thing with third person too. But what I'll say is that the syllabus here, right here in 3D, again, if you're trying to find this stuff, if you're on GitHub, you can go to just right here, modules, 3D, first person controller, and click, what you should do is you should just download the whole syllabus, right? You can just go to code and download it and clone it, and then you can find it in there. Similarly, we have a third-person controller, which I'm not going to explain because it is more complicated. But basically, what I can explain without explaining it is you just kind of need to set the character as the main point and then sort of orbit around the character. And then you need to figure out a way to not bounce through walls, so you can use this thing called a spring arm. And this isn't even the best. This is a pretty bad third-person controller, because it doesn't have, the movement is kind of weird and wrong. But what's nice about it is if you run into the wall, you get pushed toward the camera, right? We can kind of see that we're not going through this wall. So anyway, there's a decent third-person controller here, but even this could use some work. And that is all in here. That's actually not that bad, but I'm not going to explain it. Any other questions about 3D, or did I scare you off asking questions for the rest of your life? Yeah.
Wait, I know the capstone concept is how much 3D are we gonna do beyond this point?
That's to your interest. So if people are trying to make 3D games, I will teach more 3D content. I'm really it's kind of up to you all to tell me what you are trying to make towards the end of the semester, and then I really like to use the last several weeks to teach that relevant content. What I'll say is that it's not too. In some ways, 3D is not inherently that much harder than 2D. It's fairly, because of the way Gato structures things, it's kind of the same workflow. So I wouldn't be too scared of doing 3D. I've had lots of students take on 3D games for their final project and came out very happy. So if you're interested in doing 3D, I definitely encourage it. But also if you're looking at this and you're like, oh my God, no, you don't. You can kind of do this lab and then walk away from 3D. If there's interest, something that is kind of fun to do is to do character animations in 3D to get some very basic characters running around and stuff. But beyond that, that's about all there is kind of on the syllabus for it. Yeah. Is there something that you're interested in exploring in 3D in particular?
Not really. I was just wondering because we just got through your 2D
Yes.
as a homework.
Yes.
And I was wondering if there was a component of doing a 3D assignment outside of labs. But I guess at this point, it's if you want to make your final.
Yeah, that's exactly right. If you want the capstone game to be a 3D project, that's a really good way to kind of dig into 3D. What I'll say is either way, you'll still learn stuff, right? There's still plenty of things to figure out. If you're making a 2D game, there's plenty of more systems to try and figure out or design in 2D. And if you're doing a 3D game, there's all the 3D workflow stuff to do. Yeah. Any other questions? Concerns about 3D? Cool. Let's see where we're at. Because we could just call, but I don't know. Yeah, sound and characters. How's everybody's brains? Do you want a little bit more, or do you want to save it for next week?
It was a lot.
It was a lot. Great. Okay, we'll call it there then. Why don't we do that? Yeah, let's. This is a really great time to continue to develop your capstone ideas. If you want to keep brainstorming those, if you want to chat with anybody, if you want to ask me questions about missing assignments, if you want to do some of the labs, get caught up on stuff, submit stuff, I give you the rest of the class to do that. Or if you need a break and need to go home, you can go home. It's totally fine. But just remember, we do have the presentation next week, the capstone presentation. And again, for that, we want to come in with specifically a presentation that, God, come on, answers these questions, right? Tell me your concept, what you're inspired by, your influences, any mechanics, how you think the game is going to be played, how are you going to make the game with the rest of the time you have in the class, and what are you concerned about? What do you feel like you need to learn? And again, you don't need to stick to this. Your plans can change from that, but it's good to have plans. And your slides, you don't need to have slides. Slides are helpful because they help you sort of stay on task, and it's particularly helpful for the inspirations and influences. But if you're going to make slides, please don't spend 100 hours making a beautiful slideshow. I don't care. I just want to see what you're talking about. Cool? Awesome. Thank you guys so much. Thanks for hanging in there. Let me just pause. Oh, thanks for the pen.
Thank you.
Appreciate it. Yeah. Let me just pause the stream. Stop streaming.